Let's talk about hypertrophy, a topic that occupies the minds of so many youth, young men, but also a lot of women. I think one of the really interesting progressions that's taken place in the last decade or so is that far more men and women are using resistance training in order to evoke hypertrophy, growth of muscles, for aesthetic reasons and for all sorts of reasons. What are the ways that people can induce hypertrophy?
A better way to think about that question is really, what stimuli do I need to give the muscle to induce hypertrophy? Now, there are hormonal factors that are important, there are nutritional factors, but just to stick with the context of training, this is really going to frame a lot of our answers. And as you'll see, it's one of the reasons why I call hypertrophy training kind of idiot-proof in terms of programming. Now, the work is hard, difficult, and all that, but the precision needed is a lot less than what we saw in power and strength. And so if you note there, like, it's very important that you do it in this style, with this intent, and within these parameters. And if you're outside the parameters, it's not going to be it. Hypertrophy has a very broad range in terms of your actual applications. And this is why you have and will continue to see countless styles of training that all work. I know you were mentored earlier in life by one of my favorite people in this entire field, Mike Menser. Just an absolute character. His style was completely different than what you would see in a classic textbook or any number of different influencers or coaches or individuals. And if you've ever thought to yourself, like, why is it all these programs work? And people love to jump to things like, well, it's the steroids. Just get that out of the equation for now. Independent of that, or if that's not even part of the equation, you're still going to see results. And the question is, like, why? Well, that's because what's driving changes in strength and power are the adaptations of specificity. What's driving changes in hypertrophy is much more well-rounded. And so you have options to get there. Remember, you're training a movement, and now you're training a response in a muscle that causes growth. That's very, very different. So if we look at, like, the classic dogma, we have to basically challenge the muscle to need to come back, in this case, specifically bigger, and the nutrients need to be there to support that growth. Okay, the nutrients aside, perhaps we can come in a few more minutes and talk about that. So all we really have to do is, going back to our dogma of activation of something on the cell wall. We've talked about this earlier. That's got to induce that signaling cascade. That's got to be strong enough to cause the nucleus to react to it, to go to the ribosomes, to initiate this entire cascade of protein synthesis. So that signal has to be one of a couple of things. Either it has to be strong enough one time, it has to be frequent enough, or it has to be a combination of these things. All right, so I can get there with a lot of frequency and a moderate signal. I can get there with very low frequency and a large signal, more akin to what you did with Mike back in the day, I'm sure. And
still train that way.
Still train
Each
that way,
muscle
right?
group mainly once a week directly and once a week indirectly.
So all you have to do there to not fail is to make sure the training is hard enough, and it's going to work. If you choose the frequency path, then you actually have to make sure you're not training too hard to where you can actually maintain the frequency. The only wrong combination here is infrequent and low intensity and low volume. That's it. As long as one of those three variables is high, you're going to get there, because the mechanisms that are needed to activate that signaling cascade are wide-ranging. And this is why when we even see things like blood flow restriction training, right? This is when you put, like, a cuff on your arm or your leg and you block blood flow and you use no load, or as low as, say, 30% of your maximum, and you take it to fatigue failure. That actually is an equally effective way of inducing hypertrophy, despite the fact that you're using 3, 5, 10, maybe most 20 to 30% of your 1 rep max. Why? Because you went through the route of metabolic disturbance. Other ways, say a higher load, maybe as heavy as you can for, say, 8 repetitions, is going to get through what's called mechanical tension. And so there's these different paths that we can get to the same spot. Now, eventually, these things have a saturation point. So you don't need all 3 of these mechanisms. The third one, of course, being muscle damage or breakdown. And I know we want to chat a little bit about that, but none of these 3 are absolutely required. You can have multiple of them in a session. You don't have to have breakdown at all. That is a complete, well, really it's a flat out lie that you have to break a muscle down to cause it to grow. That's just not needed at all. You have to have one of these 3 things, though. And so again, this allows you a lot of flexibility which is why crafting your program, which is best for you, is actually fairly simple when it comes to hypertrophy. You just have to make sure you do the work. And you want to make sure you have a few standards in place with the exercise choice and some other things that we'll hit in just a second. But that's really the fundamental way of getting to it. Making sure either that signal is loud enough or frequent enough to give the nuclei a convincing enough reason to spend the resources. Because you have to remember two things. In order to grow new skeletal muscle, you need amino acids, which are your supply. And then you need primarily carbohydrates as the energy source to power that synthesis process. So you remember basic chemistry that says if you're going to take two atoms and you're going to pull them apart or put them together, right? That's going to take energy. Typically, in most of actually metabolism, when you split a bond, you're going to get, it's called exergonic. You're going to get energy from that. But when you put them together, that's going to take energy. This is why we call that protein synthesis, right? So you have to convince your nucleus that one, invest those resources in energy, primarily carbohydrate. But number two, and more importantly, invest that supply. There's a ton of possible ways to get energy, but there's a very low amount of amino acids available, and you need them for many more things than just taking your biceps from 17 inches to 18 inches, right? It's not going to do that if you're in a position where, again, you can't sustain immune function, if red blood cell turnover needs to be higher, or any of the other main tons of things that you need proteins for. So you have to be able to say, like, are you sure? You really want to spend these resources and build it into muscle? Because once we do that, it's very difficult to go backwards, break them back out, and bring the amino acids back into that availability pool so we can use them for either another function entirely or even another muscle group. That's called protein redistribution, by the way, when you say maybe you don't do a lot of upper body work in your training and you're not eating enough protein or a minimal amount and you're doing a lot of lifting in your legs, you'll notice your legs will get larger, but that's actually a lot of times you're pulling the protein from, say, your upper body in this case, and redistributing it back down to the quads. So that's the way that's what you have to get to.